So today we are starting off class with people checking their answers for the type 3 with a neighbor. As you're having your conversations, folks, please let me know if there's any that you would like to go over or disagree on. So first, I'm going to check answers on structure. These fill-in notes came directly from your notes on page 20, so if you didn't know where to pull that information, go to page 20. For structure, we're asked to rewrite. Number one, how am I going to rewrite this? What root do we have? Fourth root of 5xy squared. If I was just asked to rewrite, do I go any farther past that? No. So for number two, I need to clarify. We had a conversation yesterday, and we weren't paying attention to parentheses. So number two does not have parentheses, which means this 2/3 only applies to what? The x. So for number two, 2/3 only applies to the x value because I do not have parentheses including it in the argument. So for option 1 and option 2, 10 will be on the outside. What root are we taking? Third root of what? X squared. So for option 1, the power is outside. Where else could the power be located? Instead of outside the radical, inside the radical. So third root of x squared. Notice, in both cases, where is 10? On the outside. Because we do not have parentheses grouping the 10 into the argument. But then when I look at number 3, what's different about number 3? It's grouped in. So, no matter what, let's see, what root are we taking for number 3? Third root (100x squared y to the 5th). For option 1, where are we going to have the power located? Outside. What is the power? Squared. Or on the inside, 100x squared y to the 5th squared, where the power is under the radical. Because for notation, there's two. He's asking why the difference. The power can be located outside the parentheses or under the radical. So we have two ways of writing. Can you say your question in a different way? I'm not understanding. Oh, why this 2 is right here? Notice the original argument. That started as x squared, stays as x squared. Good question. Number 4, am I starting with radical notation or rational exponent notation? Radical. So I'm trying to get to a rational exponent. 7th root is associated with what power? 7th root from this side of the room. 7th root is what power? Anyone from the right side? 7th root is associated with what power? Raising to the what? 1/7. Not a trick question. 1/7. Say it with confidence. I couldn't hear you. So I write what's on the inside. What's on the inside? xy squared divided by 17 raised to the 1/7. That's it. Don't overthink it. So if 7th root is associated with 1/7, how do I say this root out loud? What do you call this root? 4th root associated with 1/4. So 5xy to the 1/4, and we're all done. Who wants number 6? Go for it. Yes, a to the 3rd b divided by 2 in parentheses. Done. Any math in what we just did? Just rewriting. So when it's a structure question and you're asked to rewrite, just rewrite. What were you asked to do for 7 through 14? Evaluate. We are going to use our charts for this. Tomorrow I'm going to print off a second chart so you can copy your charts over and have one that's out of your workbook, because today we're going to be doing a lot of flipping between the two, and B period had asked for a photocopy, and I thought that was a good idea. So I'll have that for you for tomorrow. So for today we will flip back to your chart. So if you want to put a finger where your chart is so you can go between the two. 7. How do I say 7 out loud? Okay, not the answer. Try this again. How do you say this out loud? Okay, 125 to the 1/3, or 3rd root. That's what I was looking for. 3rd root of 125 is 5. How do you say this one out loud? 5th root. 5th root of -32. -2. Can I have one voice for number 9, Shamar? What is this? 3rd root of 8. Say that all together. 3rd root of 8 is 2. Who's got 10? Is what? No solution. And we'll look a little more into this today. How about 11? Good. Is it the 4th root of -81? It's the 4th root of a positive 81. Negatives on the outside. So my answer is -3. 12. Let's just go for answers. We'll practice language with our notes. -3. 13. Careful. 3rd root of 64. 4. 14. 6. Now, as you were checking answers, I see roughly half of us have confident work shown for 15 and on, and others do not. So I'm hoping that it means you're planning on coming to see me during lunch today or tomorrow for some extra help, or that you took advantage of the time last night to catch up on your notes. Because technically last night was supposed to be flip notes, and instead, what was last night's homework? To finish the type 3, if you still needed more time, or go catch up on the notes. If for whatever reason that didn't happen last night, tonight's homework is super short, so you have even more time to go back and catch up on your learning from days 1 and 2. I'm providing every opportunity that I possibly can. Ultimately, though, what do you actually need to go do? Go do it, right? If you don't, I can't help. So come find me in the library, D period today, or tomorrow I'll be here in my classroom, D period. Google Classroom is open to you 24/7. Do it. That being said, those of us who did check our answers for 15 and on, are there any that you disagreed with that you want to talk about? 22 I heard from both sides of the room. So let's talk about 22. For 22, what are we going to do first? I have radical notation. How would I rewrite this with rational exponent notation? Y to what power? Power goes in the numerator. 2/5. Power, root. This is y to the 3/10. quotient property, we need to subtract. What are we going to subtract? 2/5 minus 3/10. Do I have a common denominator? No. What's my common denominator going to be? 10. How do I get 10? Multiply by 2. 2 divided by 2, which technically equals, what does 2 divided by 2 technically equal? 1. 2 times 2? 2 times 5? This is still the same. Now can I perform that subtraction? And get 1/10. So my answer, is my answer 1/10? Y to the 1/10. Is that done? Yes. If it had come out to be negative 1/10, would it have been done? No, I need to bring that term to the denominator. So that conversation I just had about 22, when I did the day 1 and day 2 notes, I had those types of conversations for every single question in the notes, which is why for the bazillionth time, I'm asking if you did not watch and really listen to the day 1 and 2 notes to go back and do that, or come see me for help. So 15 and on, I will check for accuracy with you tomorrow. When we come into class, I will have an answer key posted, and we will get an accuracy score for the rest of this type 3. Yes? 25, my hint to you is to factor, and there's one just like that in the day 2 notes. We need to factor for 25. 24, there's one just like it in the notes. So for 24 and 25, at the end of class, I will come back and do them, or I will point out to you where they are in your notes. All right? Let's get into our notes for today. The type 3 questions, there's one just like everyone in the type 3 in either day 1 or 2 notes. Notes for today. First, we're going to start off reviewing notation. The nth root of a is the same as a to the 1/nth power, where the denominator is still the what? N is always the root. Where did this 1 come from? Where is the 1 that's just not written? A to the first. Good. Carrying that idea forward, how would you rewrite this one? M divided by n. When we say slash, let's use the word divide. M divided by n, where again, n is the root and m is the power. The third one, what would it still be? Same. Very good. Again, for the third time, where n is the root and m is the power. And to get a visual idea, we have it here. We can label this also. N is the root, m is the power. A is the base. We are experts at evaluating, so let's use these 4 to warm up with our charts. How would I say number 1 out loud? Good. Third root of 343 is 7. Square root of 121. Very good. Is 11. Who's got number 3? But how would you say it out loud? Fourth root of 16. Is it 4? No. 2. Good. And then finally number 4. No, I already said 2. Oh, okay. So you're giving me the answer for number 4. Third root of negative 64 is negative 4. Yes. Where? Ah, good. So she's asking, before, she was looking at one that was set up like this. Correct. She said, well, why did I correct her before and say that we don't say third root of negative 64? Why in what I just wrote would I not say third root of negative 64? Because the 64 is not together with the negative. Very good. We don't have parentheses. Great question, and good for keeping that in mind. What did all of these have in common? 1 where? As the power in the numerator. What does this question ask us? And that's what our new learning is going to be about today. What if m is not equal to 1? So let's take some notes. If m, which is the numerator, of the exponent, or the top, is not 1, you must first take the root. Where is that root located? Good. Good. Take the root, which is in the denominator. You must first take the root, then raise that number to the power. So if m is not 1, we're going to take the root first, then deal with the power. Let's see how that's going to work. How would you read this out loud? Let's go this way first. 256 to the 3/4, where n equals, what's n? N is 3. And what's m? 4. Did I get it backwards? I totally did. Thanks. N is 4. Sorry about that. M is 3. Because it's m. So in words, notice it's written for you as a go-to start. N is 4, so we're going to take the 4th root of 256. So really what this is saying is 4th root of 256 raised to what power? 3rd. So mentally have this in mind. What is the 4th root of 256? 4 raised to the 3rd. What is 4 to the 3rd? 64, and we're done. It's a 2-part process. The first part is dealing with the, what first? What do we do first? The root first, then the power. What I put in this bubble is what it means, but we do not need to write this out every time. If we know how to verbally have the conversation, this, look at the smartboard, this is all we need to do to show our work. So that's going to come with practice. Let's get right into it. Number 5, what am I going to look at first? Am I looking at the numerator or the denominator first? The denominator. So listen carefully. This is the conversation. Look where I'm pointing. 5th root of 32. Say it. Is 2. So write that down. 2. 5th root of 32 is 2 raised to the 4th power equals 16. How did I get 2? What did I just use? At this point, we either know that the 5th root of 32 is 2 or go use your chart. Go use your chart. So keep a finger on your chart. It's a fact. Just like the square root of 49 is 7, 5th root of 32 is 2. And we can use our chart to help us. Number 6, what are we going to do first? Yeah, I actually don't have to rewrite because this is just evaluating. So if this says fifth root of 243, can I go figure out the fifth root of 243? Is what? 3. Is that the answer? To the third power equals 27. Are we getting a feel for how these work? Awesome. 7, what are we going to say first? Fourth root of 256 is 4. Ooh, okay, so bringing back our negative exponent knowledge. Very good. This is divided by 1, and she said that this needs to move to the denominator. So this actually equals, what stays in the numerator as a placeholder? 1 divided by 4 to the third equals 1 divided by 64. Very good. So notice how prior knowledge does come back. Who wants to take on 8? Let's try one voice so that we can follow what you say. Who's got number 8? Emily? Yes. To the negative 1. Good. So right now what she said so far was third root of 512 is 8 raised to the negative 1. Want to keep going? Good. So this equals 1 divided by 8 to the first. But 8 to the first is just 8. So 1 divided by 8. Nice. Who's got 9? Davion. Can I? So he said so far, square root of negative 16. Because it's even and the negative is located where? So really, if I were to draw myself a little mental bubble, square root of negative 16. The negative is under the radical. Is that okay? No. Is that a 5? Yeah. Is the power of 5? Yeah. So because that negative is under the radical, no, can't do it. How about 10? Who's got 10? Can we do 10? No. What's the root? What's the root? Third root of negative 64 is? Negative 4. We can take the odd roots of negative raised to the 4th. So again, as a reminder, third root of negative 64 equals negative 4. That can happen because for this to be true, it means negative 4 to the third has to get us a negative 64. Let's see if that's true. How many negative 4s is that? 3 of them. 1, 2, 3. Let's see if this works. Does this work? Yeah. Negative 4 times negative 4 is a positive 16. So that does work. All right. Is this done? Nope. What is negative 4 to the 4th? 256. Are we all comfortable with that? Yeah. Who's not? How many negative 4s is that? Negative 4 to the 4th is how many? 1, 2, 3, 4. Negative 4 times negative 4? 16. Negative 4 times negative 4? 16. 16 times 16? 256. Positive. So write that out to the side so it helps you to see it. 11. What are we going to do first? Who's got 11? Do I need to rewrite it? No, let's just straight up do what's on the inside. What's on the inside? Third root of negative 729, which is 9? Negative 9 squared is 81. Who's got 12? New voice. No, new voice, new voice. Thank you for participating. I need somebody new. Somebody new. Jeffrey. Good. Is 27. So what Jeffrey said was 4th root of 81 is 3 raised to the 3rd power equals 27. Great job. Try 13 on your own and check with a neighbor. 13 on your own, check with a neighbor. Once you checked with a neighbor, check with me. Do we match? Raise your hand if you match with me. We're good? So it's just about everybody. Front right corner, are we good? Richie, you good? Richie. Did you get 125? I'll fix it. What's different about number 14? We have some additions, but we're still going to do this one piece at a time. So for 8 to the 4 thirds, what am I going to look at first? 3rd root of 8 is 2 to the 4th. Let that alone for a second. Plus, I have 16 to the 3/4. 4th root of 16 is 2 raised to the 3rd. What is 2 to the 4th? 16 plus 8 is 24. Try 15 on your own. When would we add powers? Yes, so check it out. For you to be able to add powers, it would be 2 to the 4th times 2 to the 3rd. That would be 2 to the 7th. Jeffrey, question for me? So for a second, I just pretended like this was all I was given. If that's all I was given, I look at the root first. What is the 3rd root of 8? 2. To what power still? The 4. So 2 to the 4th. And then I pretended like this is all I had. And I said, what's the 4th root of 16? 2 raised to the 3rd power. And then I looked at it together. So 2 to the 4th is 16, plus 2 to the 3rd is 8, and that I can add together and get 24. This was number 14. 15, leave it, it's just a minus sign. Minus and negative are the same. 1 to the 5/4 you do separate of the negative. Well, let's work it through. So for the start of 15, what did you do first? Square root of 100 is 10 to the 3rd, because 3rd root of 216 is 6 squared. Minus is separate from this next term. So let the minus be where it is. 4th root of 1 is 1 raised to the 5th. So notice, I just looked at it at a piece at a time. Now I come back. What is 10 to the 3rd? 1,000 plus 36 minus 1 is 1,035. Piece by piece, folks. piece by piece. 16 did not print correctly. 16 is supposed to say, off to the side, I'm going to write 16. 16 is supposed to say 8/27 raised to the negative 2/3. Tell me what to do first. Think back to your exponent properties. Very good. Let's send in the power. So this is going to be 8 to the negative 2/3 divided by 27 to the negative 2/3. What next? It is we have negative exponents. So this has to go where? To the denominator, and this has to come to the numerator. So what am I going to have in the numerator? Divided by 8 to the 2/3. Good. Now, piece by piece, pretend that just the numerator is what I'm looking at. How would I read this out loud? Third root of 27 is 3, still to what power? Squared. Notice, though, I just took care of the root first. Third root of 27 is 3 squared. And then third root of 8 is 2 squared. 9/4. Any farther? That's it. So 16 is a great example of how our exponent properties come back. Let's take some notes. So we've talked about negatives often, but let's formalize our conclusions. So our first little piece here, what root are we talking about in these two? 3. So in general, is that odd or even? So we're going to make a conclusion about odd roots first. For odd roots, so the odd root of a negative base. Can I do that? Yes. So has a solution. So big picture, a negative sign with or without parentheses. Oops. Always get an answer. Shamar, we're writing with me, right? Yeah. Word for word, what I just wrote down, you wrote down? Let's do this together. So let's see how this is going to work. Here, the negative sign is inside parentheses or outside? Inside. So how do I read this out loud? What root? Third root of negative 27 is negative 3 squared is 9. So here, I had a negative inside parentheses. Did I still get an answer? Yes. Let's see what happens when it's outside parentheses. If it's outside parentheses, I'm literally saying negative 1 times a positive 27 to the 2/3. And that negative sign will stay on the outside the whole time. So how do I read this out loud? Is, third root of 27 is 3. So that's still negative on the outside, 3 squared. Negative 9 is my answer. That negative sign stayed where the whole time? On the outside. So with no parentheses, you have a odd root, then you get a negative. If it is n, if it's in the parentheses, then you get a positive. Be careful with that, because if he's saying, if it's inside, will I get a positive? What if this had been negative 3 to the 3rd? What would the answer have been? What's negative 3 to the third? Negative 27. So it depends on what power we're looking at. A negative to an even power will always be positive. A negative to an odd power will always be negative. Let's talk even. So we talked about odd, now let's talk even. With parentheses. With parentheses. Very good. No solution. When the negative sign is inside parentheses. Because cannot take even root of a negative. And again, just for emphasis, no solution. So for the next one, there's no solution. Yep, but let's talk about without parentheses. Without parentheses, if there's no parentheses, what does it mean about the negative? Good. Negative is outside. The negative is outside the root. And stays outside the whole time. Quickly. You do have an answer. Do have an answer. So this is something we've discussed for several days, and now we're formally writing it as a conclusion of all of these conversations. Applying this summary to these two examples, which one of these is no solution and why? The first one is no solution. Very good. We're taking the even root. What root specifically? Fourth root of negative 16, no good, because the negative is grouped under the radical. How about the one on the right? Very good. There's no parentheses, so I could actually rewrite this as negative, and then in parentheses, a positive 16 to the 3/4. And that negative will stay where the whole time? On the outside. So let's actually do this one together. Fourth root of 16, so the negative stays outside. 2 to the third, so what do we get as an answer? Negative 8. Very good. 17 to 22, we will be using a calculator. Phones do not count, so if you need a calculator, come grab one. We're going to learn how to evaluate with a calculator. So the difference here was that this is an odd root. I can take the odd root of a negative. And I can show you another example after class quickly. So let's talk about why we need calculators for 17 to 22. What is the root for 17? Fourth root of 35. Go to your chart. Go to your chart and look at the x to the fourth column. Do you see 35 anywhere in there? No. Does that mean it doesn't exist? No, it just means it's not a perfect fourth. Right. Just like way back. Can you take the square root of 36? Yes. What's the square root of 36? 6. But if I asked you to take the square root of 35, you could do it, but you're going to get a decimal. So for all of these, we're dealing with bases that do not work out perfectly. They're not perfect squares or perfect cubes or perfect fourths and fifths. So for our calculators, we need to be careful with how we enter this. It's going to be 35. What is this symbol called? What's that? A caret. And then parentheses. What am I putting inside parentheses? Negative 3 divide by 4. And then hit enter and let me know what you get as an answer. If anybody needs help with their calculator, bring it up. So for some calculators, it leaves it as a caret symbol, and for some, it actually raises you up into that numerator spot. No matter what, I want us to have a good practice of putting that exponent in parentheses. And we're going to round to 3 decimal places. So it's going to be 35. My caret is right there. Parentheses. Negative. Use the negative sign. 3 divide by 4. All right, Richie's got the answer for 17. Richie, to 3 decimal places, what's the answer? 0.06. Good. So if a 4 comes after the 9, do I need to change the 9? No. That's it. This is how we use our calculator to evaluate. 18, notice the directions have said rewrite into rational exponent notation if needed. Here we need it. So what's the base for 18? The base, 70. And then we need to build our own rational exponent. What's the power going to be? 2/3. Very good. 70 to the 2/3. Your entry is the same. 70, caret, and then 2/3 in parentheses. Let me know what you get. To 3 decimal places, please. 16.98. What comes after the 8? 4. What comes after the 4? So if it's 4/9, this rounds to 5. Anyone who needs help, come up. 19. You do. You're just going to have to be careful. It's right here. So it's going to be 70. Hit this button right here. Hold on, guys, one sec. Parentheses. 2/3. Close it. Enter. All right, folks. So what I'm going to do is wrap up 19 to 22 for the video, which is still recording. Look at your homework. What's the homework? The homework is the type 3. Nope. No, guys. Hold on. I'm not sure why we just packed up. I know the bell rang, but I wasn't done talking. So when I look at your workbooks, stay right there. If you're already standing, you're going to wait a second. We just took notes right here, yes? Yeah. Page 28. This next page is the homework. Notice, it's only one side of one page, right? It should not take you long. Now, numbers 1 through 12, it specifically says what? No calculator. On a quiz, there's going to be a no calculator section and a calculator section, so no cheating, because I may not know, but I'll know when you take the test or the quiz, right? So if it says no calculator, no calculator. This homework is so short, which means that if you still need time to go catch up on previous knowledge, do you have the time to use Google Classroom tonight? Yes. Where will I be today, D period? Library. So find me there if you need my help. I will finish putting up 19 to 22 for those of you listening to the video. Have a great day. Whose workbook do I have?
I think it's EJ. I finally got Google Classroom on my phone.
Yay! Good job. Okay, so for people listening to video, I'm back. Going through 19 to 22. For the calculator, this is going to be 7, caret, and then 1 divided by 7 in parentheses. Folks, I'm still missing one more calculator. Oh, the yellow one right there. Grab it for me. All right. So 7 to the 1/7, we should be getting 1.320. At this point, I ask that you pause the video and actually finish doing 20, 21, and 22, and then I will check answers with you. So press pause right now, and then press play when you're ready to check answers. So 20, if you're listening still, it means you already pressed pause, you've tried all three. 20 is 6 to the 1/4, which would be 1.565 if I round to 3 decimal places. 21, you get 3.178. It's supposed to be a 1. And then last but not least, 22 comes out to be 0.464. So if you did not get these for 20 through 22, please send me a quick note on Remind. Homework for tonight is the next page, which is page 28. Homework. Page 28, all of it. As I mentioned, be very disciplined. If it says no calculator, don't use a calculator. Any questions, send me a Remind. The homework is very short, so if you need time to go catch up on day 1 or 2 notes and redo those and really listen to those notes, please use your time well. This looks messy. I'm going to rewrite it. Don't mind me. All right. Have a great night, guys.